that when we are the dimensions of a given quantity is put in square brackets. So if we are writing or if we are indicating the dimension of the stadia, it is the stadia put in a square bracket. It's equal to a certain MA, maybe LB, and then TC. And this indicates the dimension of the stadia. So when you are writing the dimension of any physical quantity, it means you have to put it in a square bracket, right? So let's begin with the dimension of length. Is given by L. Eresi Osafo. Eresi.
Mr. Dia.
Hello, Eresi.
And please, the MLT at the top. Please, what are the symbols or letters or figures at the top? Here.
A, B,
yes, please.
Just A, B, C, just any represent any number. Okay.
Okay, sir. Okay, Mr. Dia. Thank you very much.
All right. So the dimension of length is L, capital L. The dimension of mass is capital M. Then the dimension of time is given by capital T. If these are the fundamental quantities on which mechanics are expressed, then let us use this to derive the dimension of area. What do you think will be the dimension of area? Yes, view. The dimension of area. Gloria.
L square.
So, because area is length times another length or length times breadth. You see, area is length times breadth, but breadth is also a length. Alexandra. Okay, so
Savior.
You raised your hand. You wanted
Please,
to.
it's fine.
Okay. So you see, area is length times breadth, but length is a length. What is a length or distance? The interval between 2 points in a straight line. So breadth is also a length. Radius is a length. Diameter is a length. So because the breadth is also a length, its dimension will be the dimension of length. So we change this to L, so that the dimension of area will be L squared. We also said that one of the uses of dimensional analysis is to determine the SI unit of the physical quantity in question. Okay, and so we can use this dimension, the dimensional equation of area, to determine the SI unit. What is the SI unit of length? Is the meter. So this is straight away meter squared. And in determining dimension, we have also used that to deduce the SI unit. Are we okay?
Yes, please.
Okay. Let's look at volume.
Yes, please.
Dimension of volume. Volume is a three-dimensional something or quantity. Length times breadth times height. Length is a length, so it goes by the dimension L. Breadth is a length, dimension L. Height, okay. Height is a length. It goes by the dimension L. In effect, the dimensional equation of volume becomes L cubed. Because the SI unit of length is meter, the unit of volume becomes meter cubed. So beautiful. Okay, let's look at the dimension of density. Dimension of density. I want to adjust the screen a bit so we could use the far end of the board. Dimension of density. I want you to try. I want you to try to obtain the dimension of density. Maame Boatima.
M over L cube.
Okay, nice try. Okay, okay. So let's quickly go through it. Density is equal to mass over volume. The dimension of mass is capital M. So the dimensional expression for density becomes capital M over volume. The dimension of volume is L cubed. So therefore, the dimension of density will be equal to M L to the power negative 3. I want you to try the dimension of the following. Trial question. And here you are determining the dimension of force, work, and dimension of power. So 3 questions to try. Start work. You are determining the dimension of force, work, and power. Alexander, finish. Hello, you have You have about 2 minutes more to finish. Okay, so let's start. Please, whilst we discuss, you mark yourself, okay? Uh, okay,
Yes, please.
Yes,
so
please.
get,
Yes,
get
please.
a red pen beside you so you can be using it to assess what you are doing. So first, the dimension of force. Force, the magnitude or the measurement of force is given by the mass of the body times acceleration. Okay, when it is about weight, when the force is about the effects of force of gravity on body, then the force becomes mass times acceleration due to gravity, and that becomes the weight of a body. But a force exerted on a body on earth moving in a straight line is given by mass times acceleration. What it means is that before we determine the dimension of force, we have to get the dimension of acceleration. So let's determine the dimension of acceleration. But the first thing is that as beginners of physics, you need to understand what we mean by acceleration. Practically, acceleration is simply change in velocity with respect to time. And let me be practical here. You sit in your father's car, okay? As you sit in the car is at rest. So the velocity or the speed of the car at that moment or at that time is zero. The engine is started, and then he steps on the accelerator pedal and it begins to move. As the car begins to move, is the acceleration zero? Is the velocity zero? Is the speed or velocity of the car zero?
No, please.
No. Is the velocity or speed increasing? Is it increasing? Is it
Increasing.
No, let's look at the scenario. You sit in the car which is initially at rest. Its velocity or speed is zero. The engine is started. The driver steps or presses on the accelerator pedal. Then it begins to move. As the car begins to move, is the speed increasing or decreasing?
Increasing.
It's increasing because initially it was zero. Okay. Now, when you have a situation where velocity of a body increases within a given time, we say the body is accelerating. So, acceleration is about increasing speed or velocity with time. Are we okay?
Yes, please.
Yes.
Please. Yes, please.
If flown, yes, let me use the word flown. It's deceleration. For deceleration, we are looking at a drop in speed or velocity with time. So when a body has attained a maximum speed or velocity and decides to reduce the speed gradually, we say the body is decelerating. When the speed is increasing with time, we say the body is accelerating. Okay, you get to understand it very well when we look at motion, linear motion. Is that okay? So,
Yes.
so acceleration A is given by the change in velocity within a certain time interval. What is the change? Initially, the velocity was 0. As time goes by, the velocity increases. So when we determine the difference between the final higher velocity and then the initial velocity, which in our case was 0, the difference will give you the change. So we say that the change in velocity is given by v minus u, where v is the final velocity, where v is equal to final velocity, u is equal to initial velocity. And of course, t represents time, the time interval. The time interval within which the velocity or speed change from 1 u to a final v. All right. So acceleration is given by change in velocity with divided by time. So we define acceleration in physics as a rate of change of velocity with respect to time. Please write that down. Acceleration is defined as the rate of change of velocity with respect to time. Are we fine?
No, please. Please, can you
Please, can
repeat
you
it? Please?
repeat it?
Acceleration A is defined as the rate of change of velocity with respect to time. The rate of change of velocity with respect to time. So acceleration A is simply v on t. Kelly,
Mr. Edward,
yes, go ahead.
I heard we can actually like define acceleration, like if they ask us to define acceleration, we can actually write the formula and define it like acceleration is equal to v over t, where v is equal to velocity and t is equal to time.
No, when you
Is
are
it
asked, when you are asked to define, you don't state the mathematical expression. Okay, if you write that, what you are saying is that we can calculate acceleration by dividing the change in velocity by the time interval. That is what you are saying. You are giving us how to calculate acceleration. Kelly, are you fine?
not really?
So when you are asked to define, we expect acceleration is the rate of change of velocity with respect to time. If the question is about how do we calculate for acceleration, then acceleration can be determined or is equal to change in velocity over time, right?
No.
So when we are marking, and I see students, instead of them to define, they write the mathematical way. Well, I'm sometimes considerate to give them half if the full mark is 1, because the question is define. If it's about explain the term acceleration, then I expect that you give me that word, okay, written definition of it, and then you back it with the how to calculate for it. Kelly, are you okay?
Yes, please.
All right. All right. So what we realize here is that to get the dimension of acceleration, we have to get the dimension of velocity and divide it by the dimension of time. So it's a two-in-one thing. We need to determine the dimension of velocity before we can get acceleration. So let's look at the dimension of velocity. What is velocity? Let's define velocity. And I gave that to you yesterday. Yes. Yes. Lauren.
Velocity is the rate of change of displacement over time.
Good. So velocity is the rate of change of displacement with time. How displacement of a body changes with time. So this is what we are saying about velocity. V is equal to change in displacement. So this is represented as delta S. In linear motion, we represent displacement by the letter S, small letter S, over T. What is displacement? What's the meaning of displacement? Anybody? What is displacement of a body?
Displacement is the distance within a specified direction.
Good. So distance covered by a body within a specified direction. So displacement is also distance. If here we want to consider the magnitude, so we will ignore the direction. And so the dimension of velocity is equal to L. Distance is length. Displacement is length. Okay. L over T. Therefore, we are saying that the dimension of velocity is Lt to the power -1. So let's apply that to acceleration. It implies that the dimension of acceleration is equal to the dimension of velocity, which is Lt to the power -1 divided by T again. When we put that together, we have Lt to the power -2. And this is the dimension of acceleration. I hope all is well. Hello?
Hi.
Please, are you okay?
Yes.
Yes,
Good.
please.
Therefore, the dimension of force becomes force is mass times acceleration. The dimension of mass is m, capital M. The dimension of acceleration is Lt to the power -2. By determining the dimension of force, we can determine the unit. This is mass. So the SI unit of mass is kilogram. Okay. And L is length. The SI unit of length is meter. T is time. The SI unit of time is second. Meaning that the derived unit of force is actually kilogram meter per second squared. Kilogram meter per second squared. But during formation of SI unit, this unit was honored to Sir Isaac Newton. And so they changed the unit, the derived unit, kilogram meter per second squared to, and was honored to Newton. Hence, everything changed to Newton. Okay? So we are also waiting for you to honor you in physics. Can you imagine calculations? Oh, 56 testing, 12 Lauren, 8 Akosia, so beautiful. Okay, all right. The other question. What's the second question? Alexandra.
Mr. Adria, yes, I have a question.
Ask your question. Alexandra, quick one.
In an examination, if you are asked to find the dimensional, if we are asked to find the dimensional equation for force, which you know force is equal to mass times acceleration, are we supposed to solve acceleration downwards?
You see, if you know the dimension of acceleration, which is LT to the power negative 2, you just put it there and multiply that by the dimension of mass. Then you go. Here, because you don't know, that's why I'm taking you through everything. Okay?
Okay, thank you, sir.
What's the second question? The dimension of what? Is it work?
Yes, please.
Okay. What is work? Work is the product of force and the distance. So we calculate for work by multiplying force by distance. So what it means is that the right hand side of the board, oh, is it? I hope it's fine. Okay, so what it means is that to get the dimension of work, I'll need the dimension of force. I'll need the dimension of force. And we've just found the dimension of force. The dimension of force. And so, Alexandra, here we will not go through. We know that the dimension of force is MLT to the power negative 2. We put it there. Therefore, the dimension of work will be equal to MLT to the power negative 2 times distance. Distance is a length. So L, giving us ML squared T to the power negative 2 squared as a dimension of work. I hope you are marking.
Yes, please.
Gloria.
Mr. Idia, please, which letter did you use to represent the distance?
Come again.
Please, I said, which letter did you use to represent distance?
Oh, distance is a length. L. Distance is a length.
Thank you.
Okay. Use yourself. Use yourself. Okay, what's the last question? What's the mute yourself. Mommy, what, ma?
Mr. Idia, please, you said displacement is represented with S.
And you also represented distance with S.
You see, what is displacement? Displacement is distance in a specified direction.
Yes,
Okay,
please.
distance is a distance. It's also a length. Length is simply the interval between 2 points. Okay, so whether the 2 points are very close to one another or is very far, they are all distances or length. And so everything distance, whether short or long, is represented by the dimension capital L, right?
Yes, please.
Please, what's the last question?
Power.
Power.
Okay, power.
Pa.
Power, okay. So the
Oh, yeah.
dimension of power. What is the formula for determining power?
Please, the SI unit for work.
Oh, okay. Let's talk about the derived unit first before we come to the SI unit. Okay, so from this is mass, kilogram. L is length, meter squared. T is time, second, per second squared. And so the derived unit is actually kilogram meter squared per second squared. Okay, but this was also honored to a famous scientist by name Joule. Unfortunately, I've forgotten the other name. It will come. When you come to school, I'll give you the other name. So it was changed from kilogram meter squared per second squared to and was honored to Joule. Hence, this whole thing changed to capital J. All is well.
Yes, please.
Okay, power. Power is also, please, the dimension of work is also equal to, or is the same as the dimension of energy. Okay, dimension of work is equal to energy. So sometimes inefficiency, work output over work input times 100%, or energy output over energy input times 100%, because they are the same quantity. Power. Power is equal to energy used over time taken, or work done over time taken. Okay. So whichever way you want to look at energy used or work. The dimension of work or energy is this. L squared T to the power -2 all divided by T. Therefore, power is equal to L squared T to the power -3. And so that's the dimension of power. Its derived unit becomes kilogram meter squared per cubic second. But this was also honored to watt, another scientist. Lauren, your hand is up.
Mr. Dia,
Hello, Lauren.
please, after solving for the dimension, are we supposed to add a derived unit? Is it compulsory, or you can
No,
just
it's
end
not.
at the derived unit?
No, I am giving giving you more insight. Okay.
Thank you.
Yes, but it's also important because we can also, test your knowledge on that. So it's good I'm adding that. All right. Your last trial under this is determining the dimension of pressure. And we will look at the other uses of dimensional analysis. I want you to find the dimension of pressure. Determine the dimension of pressure. And you help me, after that, you help me with the derived unit of pressure before it was changed to Pascal.